Okay, so good morning, everyone. So for today, we're going to have a discussions about trend analysis. No? So a sequence of series of numerical data points that are fixed at a certain chronological time order can be referred to as a time series. So the majority of the time, a time series is simply a sequence that was taken at predetermined intervals throughout the time. This enables us to make accurate predictions or forecasts regarding the requirements. So we have line chart, no, or line chart from time series can illustrate seasonal patterns, trends, and relationship between these and external factors. So exploration is the term for the process that involves using values from time series for forecasting. So time series are utilized in the majority of real-world applications, including sa weather forecasting, earthquake predictions, astronomy, mathematical finance, and essential all areas of applied science and engineering because it provides us with a more in-depth understanding of the work that we do, and forecasting assists an individual in increasing the effectiveness of their output. So to give us more details about the topic, let us all welcome our presenter. Go ahead.
A pleasant morning to everyone. I hope your morning is going well. We are honored to be able to share with you today our presentation that we have prepared on this subject. We would like to extend our gratitude to everyone who has able to make it into this morning and for providing us with the opportunity to talk about our topic. And here's Teresa Cruz to discuss about trend analysis. Next slide po.
Next slide po. Trend analysis is a process that looks at market behavior and statistical data over a period of time to produce insightful information that can be used to plan features, business strategies. It assists in identifying the key features of the market and the associated consumers. Next slide po. Displaying a summary of long-term data with the aid of trend analysis. Utilize it to examine variability at various points in time and to document how markets and consumers behave over time. Utilize trend analysis is to determine when demand is at its highest and to pinpoint periods of low demands so that appropriate action can be taken. Next slide po. Types of trend analysis. First is temporal method. This method is used to examine patterns and trends of a given group of data or study objects over a specific period of time, as well as how those patterns and trends have changed over time. Next slide po. Next slide. Second is geographic method. The geographic method can be used to find similarities and differences between user groups that are located in the same or different geographies. It is typically simple and reliable. Next po. Next is intuitive method. The intuitive method, typical a type of trend analysis, is used to examine trends within user groups in light or of logical justification, behavioral trends, or other factors perceived by futures. Next.
So, what is seasonality analysis? Seasonality analysis is a key which involves examining historical data and looking for patterns that repeat over time. It can include identifying cycles, trends, and values. It is commonly used in economic, finance, and marketing to analyze trends and make predictions. Next slide. Seasonality analysis can be particularly useful for businesses and organizations that have products or services that are affected by seasonal trends such as holiday sales, weather patterns, or sporting events. By analyzing historical data and identifying seasonal patterns, businesses can make more accurate forecasts and better manage inventory, production, and staffing levels. Next slide. Seasonality analysis is important for several reasons. Forecasting. Seasonality analysis helps in forecasting future trends and patterns based on historical data. Understanding the seasonal patterns in the data can help businesses and organizations anticipate future demand and plan their operations accordingly. Next. Marketing strategies. Seasonality analysis can help businesses tailor their marketing strategies to take advantage of seasonal patterns in consumers' behavior. By understanding when customers are most likely to buy, businesses can create targeted campaigns that resonate with their audience and their drive sales. Next slide. Performance evaluation. Seasonality analysis helps in evaluating the performance of businesses or organizations over time. By comparing performance during peak and off-peak seasons, businesses can identify areas where they need to improve and adjust their strategies accordingly. Next slide. To summarize everything, seasonality refers to seasonal variations that occur regularly in specific businesses and periods based on a particular season. A season may apply to a calendar season such as summer or winter, or a commercial season such as the holiday season. Companies that understand their seasonality can forecast the schedule, inventory, and hiring. It is done in order to align with the expected seasonality of the related activities, which results in reducing costs and increasing revenues. Next. While evaluating stocks from a fundamental point of view, it is essential to consider the effects of seasonality because it can have a significant impact on the earnings and asset of an investors. If this is not taken into account, an investor may choose to buy or sell stocks based on the operation at hand. As a result, the seasonal change that occurs as part of the firm's seasonal business cycle is not considered. Next.
Once again, good morning to all of you. My name is Julin Hito, and the topic that I will be sharing with you is all about different techniques for forecasting and some example of it. Next slide po. Papalik ako kanina sa
Hi
isang
everyone,
slide.
it's Yanis here, and in this video we will explore what is forecasting. Our past and present situation is giving us information that we can use to predict our future and make better decisions. If this is your first time on this channel, then make sure you subscribe and hit the bell icon to get updates on my latest videos about time management and productivity. Forecasting is the process of making predictions of the future based on the past and present data, and most commonly by analysis of trends. Another term that is similar to forecasting is predicting, but it's more general and less accurate than forecasting. If you think about it, almost every decision that we make is some form of forecasting, as future outcome is never certain. You might think that you will wake up tomorrow at 5 a.m., but life often proves us wrong and we happen to sleep in. Forecasting is very popular when it comes to money. It's the way how we can stay on top of our finances. When we forecast, we plan how much money will be coming in and how much money will be going out so that we can make better financial decisions. When it comes to forecasting, it's about planning ahead. People who don't forecast their finances end up with a debt and paying high interest rates. But money is not the only thing that we have to forecast. We also have to forecast how we spend our time and energy. People who don't plan their time end up wasting a lot of it, while those who do usually achieve the goals that they are striving for. To start forecasting, all you have to do is to allocate some time every week to plan your upcoming week's activities. If you start to plan how you invest your time, I can guarantee that you will be making a fast progress towards your goals. I hope that you enjoyed this video and I was able to give you a quick summary of what forecasting is and why it's important. If you enjoyed this video, I would really appreciate if you could press the like button, as this will help the video reach more people and spread the message.
Next slide ako. Thank you. Forecasting techniques. Business, governments, and individuals can all benefit from the estimation or projection made possible by forecasting techniques. Predicting future trends, patterns, and events is made possible with the use of these methods, thanks to the use of historical data, statistical analysis, and other relevant aspects. When deciding on a method of predicting, the nature of data at hand is crucial factor. Time series data, cross-section methods of analysis. Sales data gathered only a monthly basis, for instance, is an example of time series data. The lens itself well to time series analysis method. However, cross-sectional data is better suited to regression analysis because it comprises of observation collected at the single moment in time, like demographic data. When deciding on a method of forecasting, it's also crucial to take into account the needed degree of precision. Simple and fast forecasts with a reasonable accuracy can be obtained through the use of methods like time series analysis and exponential smoothing. More complicated and reliable prediction can be obtained through the use of other methods such as artificial neural networks or Monte Carlo simulation. Although these approaches can be consuming and labor intensive to execute. Next slide po. Using the writings of Joseph of Magia.com, forecasting means to guess or predict an event or trend in the future. Forecasting is how business and experts figure out what will happen in the future by looking what happened in the past and what is happening right now. Let's think about where forecasts can be useful. Forecasting is important when deciding whether to build a dam or a power plant in the next few years based on predictions of future demand. I've used forecasting. Next slide po. One example of forecasting techniques. First is time series analysis. Time series analysis is one of the most frequent methods, especially for forecasting trends that repeat over time, such as seasonal fluctuations. It involves analyzing historical data and recognizing patterns and trends in order to make prediction about the future. Depending on the complexity of data and the desired level of accuracy, time series analysis can be relatively simple or quite complex. Next slide po. Next slide po. Second is regression analysis. Is another extensively used technique for forecasting, especially for predicting the influence of variable on another. For instance, regression analysis can be used to predict how price changes will affect sales. This technique is useful for determining the intensity of the relationship between variables and which variables are the most significant predictors of particular outcome. Next po. The third one is artificial neural networks, are more advanced technique for forecasting that can be used to analyze complex patterns in a large data set. ANN are particularly useful for predicting complex patterns and inter-variable relationships, but they can be difficult to implement and require substantial computational resources. Next slide po. The other one is exponential smoothing. Is a common and uncomplicated method for forecasting short-term trends. It entails refining historical data to identify trends and patterns and using this information to make predictions about the future. This technique is especially useful when there is a high level of data volatility as it can help to balance out fluctuation and identify underlying trends. Next slide po. Next one is the Monte Carlo simulation. The Monte Carlo simulation method generates multiple future event scenarios based on probability distributions. This method is especially useful for forecasting ambiguous events such as stock prices and weather patterns. When there is a great deal of variation in the data, Monte Carlo simulation can help to identify most likely outcome based on the available information. Next slide po. Lastly is decision trees. Decision trees are graphical representation of the prospective outcomes and probabilities of a decision. This method is beneficial for forecasting the outcomes of uncertain decisions when there are multiple potential outcomes and probability of each outcome uncertain. And that's all our report. Thank you.
Okay, so time series forecasting is a method that involves making predictions about future values by employing a model that is based on the values that have been observed in the time series in the past. So the analysis of time series is essential component of machine learning. It analyzes the observed time series data, looks for securing we just simply looks for recurring patterns or trends and then uses that information to make a predictions of forecast about the future. So the process of forecasting involves using models that are filled with historical data, to make predictions about future observation. The fact that forecasting does not exactly foretell the future is one of the most distinguishing characteristic of this method. Instead, it merely provides us with a calculated estimations of what has already occurred in order to give us an idea what might occur in the future. So, a while ago, our presenter mentioned about different forecasting methods. Now, number one will be the qualitative forecasting. Qualitative forecasting is generally used when historical data is unavailable and is considered to be highly objective and judgmental. Okay? Again, the historical data is unavailable. That is qualitative forecasting. On the other hand, no, quantitative forecasting is when we have large amount of data from the past and is considered to be highly efficient as long as there is no strong external factors in play. Most commonly, 3 years or 5 years, no, better, no, for quantitative forecasting. The skill of time or the skill of time series forecasting model is determined by its efficiency at predicting the future. And this is often at the cost of being able to explain why a specific prediction was made, like confidence intervals, and even better, understanding the underlying factors behind the problem. And some general example of forecasting are government's forecast underemployment rates, interest rates, and expected revenues from income taxes for policy purposes. No? A day-to-day weather predictions, as I mentioned earlier, for the college administrator forecast enrollments to plan for facilities and faculty recruitment, and industries forecast demand to control inventory levels, hire employees, and provide training. The usage of time series model is twofold, no? So obtain an understanding of the underlying forces and structure that produce the data, and fit a model and proceed to forecast. There is almost an endless applications of time series forecasting problems. So a few of the examples from a range of industries to make the notions of time series analysis and forecasting more strong. So most commonly, forecasting the rice yield, no, in tons by the state each year, no, forecasting whether an egg trace in seconds indicates a patient is having a heart attack or not, or forecasting the closing price of stock each day, no, forecasting the birth of death, the birth or death, no, rate at all hospitals in a city each year. Pwede rin naman sa forecasting product sales in units sold each day, or forecasting the number of passengers booking flight tickets each day, or forecasting unemployment for a state each quarter, or forecasting the size of the tiger population in a state each breeding season. So we are going to use, of course, the Google New Year's resolutions data set. And most commonly, if we are going to have, if we were going to program, no, this sample, no, we could able to use, we need to import libraries, no, like, and able to load the data sets, no. So I just want to share with you some codings, no, especially for those who's studying time analysis, no, and forecasting. So wait. I just want to share this to our chat box, no, to our FB chat group, my name. As what I have here, no, what we're going to do first is to import the libraries, no, and we were going to use the matplotlib library, no, for inline SNS set. Then we load the data sets, no, by a while ago, no, we used DF, no, And this will be a sample, no, code, no, for this. If we are going to simulate, no, this code, we will be able to display this one. Then for us to change month, no, column into the date time, data type. So this will be the command, or this will be the source code, no. For plotting and visualize, no, this will be the sample code, no, and we will be able to display this graph, no. For checking, check for the trend, no, we will be able to use this code, and we could be able to display this one. Okay, as you can see, we are using the big size, no, line width, font size, and PLT.text label, no, in our program. So most commonly, this will be running through the available libraries that we imported earlier, no. Then to check for seasonality, no, we will be able to use this one, and this is the possible graph for the seasonality. Koi. Now, it is important, no, that we have an idea already on how we'll be able to do programs. No, it's not necessary for us to be an expert at all programming language, but it is important that we have one expertise, no, in a programming language. And most commonly, the most commonly used especially is of course, we have Java, no, in different programmings. So there are different components of time series, no. So time series analysis provide a ton of techniques to better understand a data set, no. Perhaps the most useful of this is the splitting of time series into 4 parts. Number one is level. So level, the base value of the series is if it were a straight line. Okay? Or in a sense that in a time series, no, okay. So again, as I mentioned, number one is level. Level is the value that would be used as a starting point for the series if it is were a straight line, no? So number two, of course, is the trend, no? So a series may exhibit a line increasing or decreasing behavior over time, and this is referred to as a trend. Number three is seasonality. So seasonality refers to recurring behavioral pattern or cycles that occur over the course of time. And noise, no? The variability in the observations that cannot be accounted by the model is referred to a noise. So all time series typically include a level, a noise, but trend and seasonality are left up to the analyst discretion. So trends and seasonal variation are typically the most prominent aspect of many types of the time series. And one more characteristic shared by the vast majority of time series is the tendency for observation made in the close proximity to one another in time to be correlated. So the observed time series is the result of these components interacting with one another in some other way. For instance, they might be combined in order to produce a model. Of course, like yung ating y is equal to levels plus trends plus seasonality plus noise. No? So, and this will be an example of what I have mentioned. Okay, so this will be an example of residual, seasonal, trend, and observe. Okay, now, that component, no, are the most effective way to make predictions about future values, but may not always work. So that depends on the amount of data we have about to pass or to the past. Next will be the analyzing trend. No, so I think our presenters now also discuss about the analyzing trends. So Checking out data, no, or conducting a trend analysis involves examining data in its graphical representations to look for recurring patterns of behavior. And this aspect of data analysis is typically not very challenging as long as the trend is consistently moving in either directions, like either upwards or downwards. In the event that the series data contain a significant amount of error of any kind, the first step in the process of trends identification is smoothing the data. So, smoothing is the process. The process of smoothing always involves some form of local averaging of the data in such a way that the components of individual observations cancel each other out. So, the moving average smoothing method is the one that is utilized the most frequently, and this method involves replacing each element of the series with a simple or weighted average. No? Simple or weighted average of the elements that surrounding it. Most of the time, median are used in place of means. So, when compared to moving average, smoothing, no, the primary benefits of median smoothing is that its results are less likely to be skewed by outliers, no, that occur within the smoothing window. The most significant drawback of using median smoothing instead of moving average is that in the event that there is no obvious outliers, it could result in more distorted curves. So in the other less common cases, such as when the measurement error is quite large, the technique of distance weighted least square smoothing or negative exponentially weighted smoothing could be utilized. And these techniques have a tendency to ignore outliers and produce a smooth fitting curve as the result. So, to fulfill a purpose of rule, in the event that there is an obvious repetitive non-linear component, the data will initially require transformation in order to get rid of the non-linearity. So, in order to accomplish this goal, a log, no, exponential or polynomial functions is typically utilized. Now, in order to get better grasp on this concept, I just want to show you an example, no? Again, on how we'll be able to understand this series. No? So this will be a sample code. No? Let's say, for example, then this will be the possible graph result. No? So from the diagram, we can easily interpret that there is an upward, no, trend for gym every year. Okay? So, another is the analyzing seasonality. So, analyzing seasonality, no, the repetition of data at a predetermined time interval is what we mean when we talk about seasonality. And this is an illustration of seasonality. For some reason, we always seem to notice that the most popular time of people to take vacation is between the months of December and January. Time series analysis possesses this quality, which is another one of its most important aspect. So after deducting the trend from the data, the autocorrelation is typically used as the method of measurement. Okay? So, I just want to show you again a sample codes and output. So as what we have here, so this will be the code and this will be the possible output. And this will be started from 2005 to 2017. Okay? Now, based on the given graph, no, it is clear that there is a spike at the starting of every year, no, which means every year, no, January from people trend to take diet as their resolutions rather than any other month. And this is a perfect example of seasonality. Okay. So our presenter also discussed about moving average model. Okay. So okay. So there is an additional source of information that can be modeled, no? And that source is the residual errors that come from forecast in a time series. So a time series can be formed from the residual errors, no? It is possible, no, to use an auto-regression model of this structure to anticipate, no, the forecast error, which can be then be used to correct forecast. And this process is called backwards corrections. So the residual error may contain structure in the form of trend, bias, or seasonality, all of which are amendable or amenable rather, no, to direct modeling. One is able to create a model of the time series of residual errors and then predict the expected error that the model will produce. After that, the error that was predicted and can be deducted from the model's predictions, which will then result in an additional improvement in performance. So, we have what we call okay. So, we have what we call ARIMA, no? So, ARIMA stands for Autoregressive Integrated Moving Average. So, the ARIMA is an analytical tool, no, which is very important concept in the fields of statistics and econometrics, in particular the study of time series. So, ARIMA is a method of forecasting that provides us with values for the future that are solely based on its inertia. So, ARIMA model incorporates a well-defined statistical model for the symmetrical components of a time series. No? And this model allows for the presence of non-zero autocorrelations in the irregular components of the same time series. So, ARIMA models are defined for stationary time series. Therefore, if you begin with a non-stationary time series, you will initially need to difference the time series until you attain a stationary time series. And this process must be repeated until you have a stationary time series. The stat models library allows for the following steps to be taken in the creation of ARIMA model. Number one, define the model by calling the ARIMA functions with the P, D, and Q parameters that were given. In these steps, the fit functions is called on the training data in order to prepare the model. And utilizing the predict functions and providing an index that specifies the time or times that are to be predicted enables one to generate a predictions. And this will be an example of a code. Okay, so import the library. And let's say, for example, this example actually is, we're going to use the data set called shampoo sales, no? So, okay, I think somebody are doing a pharmaceutical sales. And this will be a good example, a code, no? Using a RIMA model, no? So if we're going to have this code, we could able to simulate with this value. Okay, so then afterwards, we have ACM, no? ACM and PACM. So in ACF and PACF, we are able to calculate the correlation between the observations of a time series and the observation of earlier time series, which are referred to as lags. No? And this type of correlation is known as serial correlations or an auto correlations because it is calculated using the values of the same series at earlier times in order to determine the correlations of the time series observation. The autocorrelation functions, also known by its acronym ACF, no, is a plot that displays the autocorrelations of a data set that contains a time series organized by lag. This type of plot is also known as autocorrelation plot of a correlogram in some circles. And this will be an example of ACF and PAF. Okay, so from stat models that graphics that TS plots, no, we could able to define the plot that act data, and we will be able to display the autocorrelations value from 0 to 3,500 and from 0.5 to 1.0 to find out the autocorrelations. Okay, then another thing, a partial autocorrelations, no, on PACF is a summary of the relationship between an observations in a time series with observations at a prior time steps with the relationship of in between observations removed. So example that, no, from stat models that graphics that TS plots, no, we could able to use this one and to display the partial autocorrelations. Okay, so this will be the possible results. Now, again, it is simply, no, that the topic itself, as what our presenters mentioned, and with my additional discussions, that the time series, no, is one of the most important aspect of data analytics for any large organizations. No, again, for any large organizations, time series analysis is one of the most important aspect of data analytics because it helps in understanding seasonality, trends, cyclicality, and randomness in the sales and distribution, as well as other attributes. And these elements assist businesses in arriving at decisions that is both well-informed and highly important for their operations. So I think that's it for this topic.